Alrighty, welcome everybody to the panel discussion about the Ligo movie you just saw. I'm John Mulcahy. I'm an astronomer by training, the director of the Carnegie Observatories in Pasadena, California, and the science deputy for the Carnegie Institution for Science. And so I have the pleasure of moderating the session today about the film and about LIGO. I'm going to let each of our speakers introduce themselves. We'll start with Tony.
Hi, I'm Tony Piro. I'm a scientist at the Carnegie Observatories in Pasadena. I'm a theoretical astrophysicist, and I study the universe in its most extreme states, so things like neutron stars and black holes and gravitational waves like you saw in the movie just now.
Les.
I'm Les Guthman. I was the director of LIGO and writer of LIGO, and I just want to thank the DC Environmental Film Festival for setting up this panel and including the film. This is my 6th film at the DC Environmental Film Festival, going back to the Hudson River Keepers in 1998.
Oh, great. Maria.
Hi, I'm Maria Drought. I am an assistant professor in astronomy and astrophysics at the University of Toronto, and also still a research scientist at Carnegie Observatories as well. And I'm an observational astronomer. I mostly study explosions in space, including the explosions that occur at the same time as many of the gravitational wave events that you saw in that film.
Great. So why don't we jump right in, and I'm going to start with you, Les. So, LIGO's a really great instrument. As we know in science, it's been an amazing accomplishment. I'm wondering what attracted you to LIGO, and why did you decide to do a documentary on this particular project?
Well, I was invited by the LIGO laboratory to make the documentary, and I've known Barry Barish for many years, so I knew about LIGO, and I just jumped at the opportunity because, and this was before they made the detection. We did our first shoot at Caltech 2 months before the detection, and I interviewed Barry and Kip Thorne and Norna Robertson and Dave Reitze, the executive director, and they told me it would be a year to a year and a half, maybe 2 years. One person, even one future Nobel Prize winner, said it could be 5 years. So, and they said, "Are you willing to hang with us for this amount of time?" And I said, sure, because it was such a great project, and as we'll talk about, as you saw in the film, I was so pleased to have the opportunity to make the film.
Yeah, I mean, LIGO, one of the interesting things for me, and I think the astronomers can comment as well, LIGO's gotten lucky in a few ways, and it sounds like you got a bit lucky too with your timing. I mean, one of the remarkable things when I was watching the film was just, you were right there, right when it happened, and that must be pretty exciting.
Well, we went 3 weeks after that first shoot at Caltech, we went to the LIGO Livingston Observatory in Louisiana for the launch of this new upgrade that you saw in the film, Advanced LIGO. And of course, it happened at 4 a.m. So we weren't literally at the observatory when it happened. And in fact, the 2 operators who were at Livingston and Hanford didn't know it happened because the voice alert system that they would have in place had not yet been working properly. So the signal came into the computers at 4 a.m. We were, of course, in our hotel room in Baton Rouge, but we planned to come in for their normal 8 o'clock in the morning meeting. And this was 2 days before the formal launch of the upgrade. And we walked in, and their world had changed. Presumably, there was a lot of doubt, of course, but as we say in the film, that the Nobel Prize winners had been working on this for up to 50 years, Ray Weiss and Kip Thorne, and Gabby Gonzalez, who was based at Livingston, is professor at Louisiana State University. She had been working on it for 25 years. And the other thing that I really couldn't get into in the film, but which you will all appreciate, is that everyone from the most senior physicists to the grad students, if not the undergrads, told us that they were advised when they said they were going to do their PhD in gravitational wave physics and join LIGO. They all said, they were all told, "Oh, you're wasting your career. This is this is never going to happen." And I heard this story over and over again. Even Sarah Gosen, who's in the film, who was at that time a graduate student at Caltech, she told me that. She said, when I said I was going to come to LIGO and work with and get my PhD in gravitational wave astrophysics, everyone told me, "Oh, you're wasting your time. Do something else. It's never going to happen." So as a result, many of the physicists and engineers around the world are risk takers, and many of them risked their careers. You can speak more. When I interviewed Franz Cordova, as you saw in the film, I said, well, I said pretty much the same thing, but I slipped and I said that this was a sketchy area of physics because of the false claims that had been made in the past. And she jumped on me because she had studied with Kip Thorne for her PhD at Caltech, and no one was going to criticize gravitational wave physics. So it wasn't a sketchy corner of physics, but it was a corner which had not been successful after a long period of time. And as early as 2012, there had been a false detection announced. So anyway, all of that is sort of a preamble to walking in that morning, and for all these wonderful physicists and engineers who had risked their careers, suddenly it might have been all worth it.
Yeah, no, I mean, I think all the astronomers I know will remember that. We had heard rumors that this was coming for a few months before it was actually released. So let me actually ask. So maybe Tony, when you first heard this, what did you think? I mean, you spent your whole career studying things that this instrument is really designed to detect.
Yeah, I mean, I spent a lot of my time speculating about different things they would detect and the different science LIGO would do. And like was well covered in the film, I mean, there was a long history going up to this, where the original designs of this were like in the 60s, there were prototypes in the 70s and 80s. And, even through the early 2000s, there was a lot of benchmarks that LIGO needed to make to be able to detect gravitational waves. And even though they didn't think they were going to detect anything, they were able to meet each of those benchmarks really well. So it was really a proof of, the organization and how well they were going to, marching toward meeting these goals. And so, I wasn't surprised they eventually saw it, but just how early they saw it, just the amazing part where it was during this very early test phase that they ended up catching these gravitational waves. And then just the fact that there were these 30 solar mass black holes in our own galaxy. The black holes that we know about are mostly around 10 times the mass of our sun. And so there was maybe some speculation, but maybe not expectation that we would see such large black holes merging with LIGO. And that was just incredible when we heard about that and saw that very clear chirp signal that was highlighted in the film.
Yeah, so Tony, let me follow up on that. Or actually, maybe let me ask Maria, spread the wealth around here. It was one thing I've wondered about. I mean, did I said earlier, LIGO's gotten lucky, and they have in some senses. We know some timing things have worked out really well. We'll talk about the 2017 event in a little bit. But I'm wondering, in terms of the black holes, were they just more successful here simply because the black holes were bigger than people were expecting?
Yeah, absolutely. Well, at least that was something that really contributed to it, because what they can detect depends on the strength of the signal. And the larger the black holes are, the further away they can see it. And so the further away you can see, the more universe there is to look at. And so even just how many things they were able to detect before we knew that you definitively could have black holes this large, it was unclear that they would detect it because we didn't know they existed. So it really was a huge advance there. And now, of course, they've detected dozens of similar events, and really it's now a sample of events that we can use to study where they form in the universe.
Yeah, what I love about it is it shows how little we know. We often think as astronomers, astrophysicists, we have a good idea of what's going on. The universe always surprises. And I always say, anytime you build a new telescope of any sort, or a new facility of any sort, it's the things you're not expecting that are the most interesting. And LIGO has certainly proved this, I think, in a really big way. So Les, let me ask for you. So this excitement happened. You were there right when it sounds like you really started right before these first detections by a few weeks. And then I'm wondering, like, how long did you, are you still following? Is this a process where you were there for years? Because it's been a few years now since this, or how is that working?
Well, we filmed through the 5 months that they kept the detection secret, and hope that none of you would tweet it out. And that was a serious issue because, what the implications would have been if the secret had gotten out. So that was not, that was a serious concern. But also they were worried because the signal was so clear that they might have been hacked, as you saw in the film, or that they might have been sabotaged. And I think CERN had been hacked a couple of years before this, so it wasn't out of the realm of possibility. So there was a period of time where they focused on that question of could it have been either an inside job or could they have been hacked? And then there was great concern, as we showed in the film, that they wouldn't make the, you might want to talk about that a little bit, they wouldn't make the claim without a second detection. And there were too many examples of, and one famous example at Stanford where a different kind of detection was claimed with very good evidence, but later turned out to be false. So they felt the worst thing they could do was to make an announcement without a second detection. And I think Ray, among others, and Barry Barish were very strident about that. And then on the Christmas night in Europe, or I guess it was the 26th in Europe, they made a second detection. And so we kept filming through that. But when they finally made the announcement in February of 2016, I sort of thought that was going to be our last shoot. And but we were going to continue. Part of my National Science Foundation grant includes the 8-part video series that's now on YouTube. So we were going to continue filming, if only to continue documenting the work that they were doing and to fill out this series. But I sort of thought that the film was done, and I began working on the script, and we continued filming. And then, you know, as we're going to talk about, they made this spectacular discovery of 2 colliding neutron stars. And then a couple of months after that, in October of 2017, the Nobel Prizes were announced. So our final shoot, in fact, turned out to be just an unforgettable week with our 3 main characters in Stockholm during Nobel Week, which was just magic, really.
Yes, I would say that was the least surprising Nobel Prize in physics ever, maybe. I think we all kind of knew where that was going. That just shows you how spectacularly good the result was here. I mean, everybody understood, you know, 100 years after Einstein, you know, confirmed this, and it was a no-brainer. And so this is pretty exciting. And we all know those individuals, and we're really happy that this worked out well for them after spending such long careers. I mean, this is the thing, I think, none of them are young. They've all had dedicated decades to this problem, right? I mean, this is, and so it's really great to see an end result so positive for them. And it's great to have it documented in such a great way. Tony, why don't we jump into the neutron star, because, you know, black holes are interesting. I think, you know, everybody thinks black holes are interesting, but, you know, why was the neutron star event such a big one? When we'd already seen the black holes merging.
Yeah, so neutron stars are of course these dense cores that are left over after massive stars die in supernovae. And these are really extreme things. You heard in the film the density of these things. 1 cubic centimeter of a neutron star has the same mass as basically all the humans on Earth. And these things are basically like 1.5 times the mass of our sun and about the size of a city. And these are the sort of extreme objects you need to have spinning together to produce these gravitational waves. But what's really different about neutron stars versus black holes is you actually have material associated with them. And so when they collide, they rip each other apart and start spewing out this material, which is, as the name suggests, very neutron rich. And this material is unstable, and it synthesizes heavier elements and produces radioactive material, which then glows, which allows astronomers to actually contribute as well, actually follow these things up and look at them in light, which allows you to study these things in a completely different way. Now you have both the gravitational wave information, and then you have the electromagnetic information from the light you're seeing from these events at the same time.
Yeah, so Maria, I'll let you go on from there, because you, of course, you and Tony were very involved, of course, in the optical detection of the 2017 event. So maybe you want to tell a little bit about that, how that happened, you know?
Yeah, absolutely. I could tell a little bit of the story of that, how we managed to find it. Because as Tony said, when we first heard that LIGO and Virgo had actually detected a neutron star merger, there was so much excitement because it really meant, we knew that that meant this was our best opportunity to find light from the same source, which, as Tony said, opens up so much more science. And when this happened, we got the notice sometime early morning in California. I was in Pasadena at the time. And it became clear that this was going to be our best option, especially because LIGO was going to be shutting down in a few weeks. So this was our best, if only option for a while, to find light from one of these sources. But we knew we were going to have to look and search for it because LIGO and Virgo, they don't pinpoint this is exactly where in the universe this happened. They tell you it came from this part of the sky that's the size of like 150 full moons or something like that. So we knew it came from that general area and we're going to need to find it. And we quickly that morning figured out that our telescopes in Chile, Las Campanas Observatory of Carnegie's, for example, they were going to be the first observatories that would have the chance to look for this in optical light anyway. Gamma rays were seen right at the time from telescopes, but looking in visible light, we were going to have the first option. But that patch of the sky was only going to be above the horizon for about an hour at the beginning of the night. So we suddenly knew we had about 8 hours to prepare for 1 hour to look for something that no one had actually ever seen before. So we got to work. And of course, we had been working on, we knew this could happen for years. And so we had a general plan, but we had to get to work. We ended up, our team was operating in parallel 3 different telescopes at Las Campanas Observatory, both Magellan telescopes and the 1 meter Swope telescope. We decided to use all 3 of them to look for it using slightly different colors of light, blue, red, and infrared. And in the end, we had an hour and it took about 15 minutes. So in something like the 7th image we took on the Swope telescope, our colleague, Charlie Kilpatrick, who was looking at in real time the images from that telescope, wrote the most understated message to all of us possible. It was something like, I think I might have found something. I think that's what he said or something, but he sent the image over and it was beautiful. This was an image that was shown in the documentary that just shows a galaxy and like a red arrow to a new, what looks like a star just up to the upper left. And I got chills when I first saw it, actually. We didn't know for sure that that was the event yet, but it looked so perfect. We knew that these sorts of things usually happen around elliptical galaxies and slightly offset. So it just felt right. And then we ended up confirming that it was the case and following it for almost 3 weeks afterwards. And that allowed us to do, as Tony said, studying that glow or that fading glow from this emission let us learn that the heaviest elements in the periodic table really are made from neutron star mergers. And we knew that because we saw this light, but also because LIGO and Virgo had detected gravitational waves from the same thing. It was only with all of that that we were able to piece it together. It really was, I mean, astronomy is always a bit of a hunt and chase and a little like forensic science, but this was the most sort of intense experience like that I've ever been involved in.
So thank you for that. It was, and I should point out for those of you people who don't remember that we had the big solar eclipse that almost all of America was trying to observe. And I know in my case, I was in a remote part of Montana when I got the phone call that this was going on, and everybody point all the telescopes, you know, we need to override everything to make this happen. And thankfully it worked out. It's very exciting. And of course, the first of many such discoveries. We've actually already run out of time, believe it or not. Okay. we could talk about this stuff for hours, but let me ask you just one final question, which is, you know, the festival this year is being done virtually, as is everything because of the pandemic. And at Carnegie, we've had to do all of our things virtually. It's a new world in some sense, but I'm wondering, as a long time science educator, reporter, as you are, how you feel the pandemic may be impacting the public's view of science? I'm just curious if you have any take on that.
I have a maybe different side to that question. One thing, when you asked me what attracted me to the LIGO story, this is true of all of science, but this was a perfect example of a relentless search for truth. And I hope that came through in this era in which truth is, you know, so much called into question. And I think that it may be that rather than the Marshall McLuhan question you asked about medium, was the medium the message, or is the medium cool or hot? I hope that the public, because of the final triumph of science over superstition, will get a better understanding of how science works and and the value of science and the value of truth. I don't know, the jury may still be out on that, but I would say that is the probably the greatest impact of the this is the best answer to your question, I think.
Yeah, and I think the film did a really great job. That's the thing as a scientist, I really enjoyed about it, was because they did take those 5 months to look at the data, right? They didn't rush out and publish it the next day and say, we found a gravitational wave. They were very, very cautious and very concerned, and they went through all the various steps to convince themselves that what they had was real. And this is, I think, something that's often not appreciated by the general public so much. I mean, science is, we're here to try to find the truth as best we can. And we tend to be pretty cautious about it because we don't want to, we want to make sure we really understand what the data is saying. And I think your movie really captured that very beautifully. So
I'm very glad
on that. It was just a really wonderful film, very exciting. So I guess we'll wrap up at this point. Let me just thank our panelists for joining us today. And I want to thank the audience for joining for the film and here. And I hope everybody enjoys the rest of the festival and continues to watch these amazing documentaries about science. And so I hope everybody from there will say goodbye. Thank you.
Thank you.
Bye. Thanks.
Thank you.
Thanks so much.